Thank you, everybody. Hopefully you guys are having a good conference so far. So as he mentioned, my name is Karim Ani, and I'm the founder of Mathalicious. So I'm the founder of Mathalicious, and what we're doing at Mathalicious is we write lessons at the middle and high school level around real-world topics. So we provide classroom teachers with lessons that help them teach the Common Core standards, but through real-world topics that really challenge their students to think about the world differently and think more critically. And I'll show you this in a moment, but before I do, just kind of want to set the stage for certainly math education in this country. According to a 2012 Raytheon survey, over 40% of middle school students say they'd rather take out the garbage than do their math homework. And when you ask them why, they often say, I don't know what this means, and I don't know when I'll ever use it. And I don't know when I'll ever use it. That's certainly something that we've said a lot in this conference. And so to these students, mathematics is a bunch of random skills to memorize and regurgitate, right? Do this, then do that, a bunch of procedures. And teaching like that isn't fun either. So the engagement question isn't just for students, it's also for teachers. Lots of teachers around the country are saying, why am I teaching this? And so really the narrative here is we've got students and teachers across the country asking this question. Why math? Why do I have to learn it? And why am I teaching it? And so at Mathalicious, we offer them something to help answer that question in an engaging way. So we, again, write these lessons around real-world topics. For instance, how long would it take to burn off a Big Mac? And what would happen if McDonald's rewrote its menu in terms of exercise? In the Olympics, do taller sprinters have an unfair advantage? And what would happen if Olympic races were organized proportionally, if Usain Bolt had to run farther than everybody else? How was the original iPod depreciated over time? And what is the likelihood of finding life on other planets, and is it something that we should actually expect? So I'll just give you a couple quick examples of what these lessons look like. Again, these are for classroom teachers. So there's a lesson at the 6th grade level, Wheel of Fortune, and what students do is they analyze the wheel and determine how often as a percent they would expect each amount to come up. So bankrupt, for instance, we would expect to come up around 11% of the time. So for every 100 spins, we would expect 11 bankrupts. So is that what happens? Can you turn the volume up, guys? What's happening is it turns out when students watch the episode in class, it turns out that bankrupt actually comes up closer to 15% of the time. So from students' perspective, the lesson is about this. I would have bought the vowels, but they cost $250. But from the teacher's perspective, it's about this, but it's also about this as well. All of these Common Core standards, right? Understanding a percent as a rate out of 100. Theoretical versus experimental probability. Not just the content standards, but it's also about these mathematical practices, the higher order skills that really underlie Common Core. Construct viable arguments and critique the reasoning of others. Certainly there's a 6th grader who's going to say, I think Wheel of Fortune is rigged. And another's going to say, we only watched one episode. Maybe we should watch more. Give you another example. So, why math? Because it's a tool to determine whether Merv Griffin is shady. Here's another lesson. There's a website. I don't know if you all know it. There's a website called Nike ID. You can go and you can customize a pair of shoes, and it's incredible. You can customize all these components. And so the question is, how many different color combinations are there? Fundamental counting principle, right? How many different color combinations are there? 1,000? 10,000? Well, when students do the math, here are all the components. When students do the math, it turns out that there are over 100 million possible colors. And so you can imagine students' response to that. 7th graders like, oh my God, that's awesome. Any shoe I can think of, I can design. That's so great. But it turns out, in the lesson and where the narrative goes, this is a psychologist from Swarthmore named Barry Schwartz. You might have heard of him. And here's what he says.
All of this choice has two negative effects on people. One effect, paradoxically, is that it produces paralysis rather than liberation. With so many options to choose from, people find it very difficult to choose at all. The second effect is that even if we manage to overcome the paralysis and make a choice, we end up less satisfied with the result of the choice than we would be if we had fewer options to choose from.
So I see a lot of heads nodding. So we start with a lesson about the fundamental counting principle, something tree diagrams that students do, but then it transitions into a conversation about the psychology of commerce. Can you imagine how smart 7th graders would be if these are the conversations they were having around the country? Give you one more example. So it is video game season. Xbox and Sony PlayStation in the past 2 weeks just announced their newest consoles, and it might be worth looking at how video games have evolved over time. Here's some football games. This is from the Atari. So we got some Tecmo Bowl fans in the house. So in this lesson, it's called Xbox Exponential. What students explore is how have video game consoles evolved over time. And you guys might have heard of something called Moore's Law. Moore's Law predicted, this Gordon Moore, computer scientist, predicted that every 2 years computer processing speeds would double. And so in this lesson, students explore whether that's been true. Starting with the Atari 2600, they determine the exponential growth equation and use that to predict other consoles, which they then research and find that other consoles have been historically slower. And the last thing they do is come up with the exponential regression to really model that and then predict what will these games look like in the future. Will there be a point at which games are so realistic that we can live inside of them? This is the situation we have now. We have students who are bored out of their skulls. And we have teachers who are as well. Teaching job satisfaction is at its lowest point in over 2 decades. Because everybody is asking this question, why math? Why do I have to learn this? Why do I teach this? And in Mathalicious, we think that the reason is because it turns out that the world is a really interesting place. And it's full of very interesting questions. And mathematics is a tool that we've created to answer those questions and then to ask more. And so what we're doing is providing teachers around the country with lessons that help them do that. Thank you.